Okay, today's topic is the history of the internet. Dun dun dun. Okay, so we'll divide this into two stages. Number one, before the World Wide Web, so roughly before 1994, in those years, the internet was a specialized tool for specialists. And the other side is, of course, the post-World Wide Web. That's really the divider. After the World Wide Web was introduced, you had browsers like America Online. Eventually, ordinary people start buying and selling over the internet. Ordinary people use email. That's what we're in now. And there are a few stages in there. So right now, you could say we're still in the cloud stage. It was interesting. When I first started putting this course together, I thought in my own head, what makes the most sense as the big breakpoints in the progress of the internet. And we had a little window in the 90s where people weren't sure about the internet. Ordinary people started to adopt it. That lasted for about 5 years. By about 2000, a lot of people had internet in their home and were fairly comfortable with buying stuff online. So that was the adoption era. Then the shakeout era was approximately the dot-com bust. So you had all these small businesses trying to get big, but there's only so much space in the world. They couldn't all get big, and a lot of them got crushed by the competition. So that happened for a few years afterward. Then you had the mobile era, right, with notable events like the iPhone, and we make this transition from everybody doing internet at home to people doing a lot of internet stuff while they're out and about, with various apps like Facebook becoming prominent during that time. And then the cloud era. From about 2011 or so onward, businesses are adopting the cloud as a way of dealing with their own problems of scale. And we're still more or less in that right now. You could argue that there's some more stuff on the horizon, but cloud is a pretty big thing. So anyway, these were the four main events that I thought of when I started putting this course together back when. And it was kind of happy for me to see. Then afterwards, you know, I looked around on the internet and saw how other people had broken it down, and they tended to break it down along these sort of same lines. So these are the big four stages. And even though, you know, I was mostly drawing on my own experience to come up with that, I didn't just entirely pull it out of my ass either. Okay, so let's go on. Now, if you look real close on this, you can see over at the bottom left here, this is 1991. So the growth in internet has been really huge. For a long time, it was not very big. So hosts and users in millions. Even around 1998, you're still only talking maybe somewhere between 50 and 100 million, right? It's a pretty small slice compared to what we have now. Nowadays, you know, we have about 100 times that, right? So if that's like 40, say that's 40 million there, 50 million, then boom, right? We're surely around 5 billion up here by now. So lots. It's way bigger, right? So what was happening 20 years ago was just a few percent at most of what's going on right now. So way bigger. So it happened in basically three stages. The first stage, read-only web, was basically people show up and they look at stuff. So the nature of that is basically you're some research operation or some sort of business that's sharing information, something like that. You have documents, people show up and read them. And on your side, people occasionally edit those documents and upload new versions of them to the servers. But ordinary people, ordinary end users, do not have the capability to edit that. So that's what it is, the read-only web. And it largely functions like a newspaper, right? There are people who write it, there are people who write the content, but the ordinary users don't have that sort of back and forth with it. But that started to change a little ways in. You had what they called the read-write web. Okay, and that's a much more interactive experience. So what that means essentially, ordinary end users can update the pages, and those updates are transferred to the servers automatically so other users can see them. So think of it essentially as document sharing, but document sharing being very pervasive. The obvious example in there, Facebook, right? Facebook, you show up on Facebook, people have posts, you comment on their posts, those posts get echoed out and everybody can see them, right? So that's what we mean by read and write. The ability to change content is not restricted to the people that own the server. Then Social web. Okay, so a whole lot of applications geared around large populations of users interacting with each other. So again, Facebook is the leading edge of that, right? And before that, of course, MySpace. Uh, but YouTube, people don't often think of YouTube as a social media site, but it is. It's just primarily sharing content through videos. Other things, various apps that we've all seen lately, things like Uber, things like Airbnb, where people can sell services over the internet that would not have been possible just a few years prior. So that's what we mean by the social web. Okay, I will also add in one footnote here. This is a personal footnote for me. So Mosaic, this was a Mosaic, one of the early web browsers that led to a commercial product called Netscape Navigator that was for a few years in the 90s a very strong competitor to Microsoft's Internet Explorer that was the default web browser at the time. What do we have here? We got a chat. Yes, exactly. UIUC made that. But more to the point, the personal connection for me, there was a large cluster of people that were at the high school I went to for a while. They came down there. They were computer science people. Had I majored in computer science instead of finance, and had I been fortunate to latch onto that, I could have been part of that team, right? It was going on right there, but you don't know what's going on in the world unless you're paying attention to this sort of stuff. So anyway, what I'm saying is opportunities are there all the time. They might be very close to you, but you don't have any idea, right? Because you don't see what's coming. So that's all I can tell you about that is be out there and listening for what's going on, or the world may pass you by. All right. Not that the world exactly passed me by, but I'm saying, you know, I could have been one of these tech people and, well, I'm not. Okay, moving on. Why is this not, why is this, there we go. So in the early days, pre-1960, right, what was the state of computers? Well, there weren't very many of them. And the ones that were there were very expensive, very clunky, relying on things like vacuum tubes and punch cards, okay? So we have one very old fellow in our department, Stan Sklove. He teaches a lot of data mining type things. Stan is in his 80s, and he actually worked on these kind of old computers back when. So, you know, he could tell you some interesting stories about this if you want to hear about it, about the way things used to be. For me, punch cards were something that I saw, but never used them. Anyway, so back in those days, programming computers actually meant physically flipping the switches. So you didn't like type in computer instructions into a monitor and then, you know, have that show up as source code. You actually physically flip the switches into the correct positions to execute particular computer instructions. So it was really clunky. It took a while. It was easy to make mistakes. And so this was something that, you know, was very, very tedious. The other thing, data transfer was very, very slow in those days. So even think about in the 90s, you were doing pretty good to have a dial-up connection that got you like 57K, 57 kilobits, right? And connection speeds are 1,000 times faster now. You know, we get like hundreds of megabits per second. So very slow data transfer. So what did all this mean? Well, number one, you design a particular system for a particular task because reprogramming a computer was a giant hassle. And every time something went wrong, that took time. So imagine if you program your computer to do payroll, right? You have it do payroll, it sounds great. You switch to do it some other application, you code that up, you get it working, and then you want to put it back into the payroll configuration. Well, it's easy to make a mistake doing that, isn't it? And if you do make a mistake, then what happens to the payroll? It gets delayed. And if payroll gets delayed, then people are unhappy. So you don't want to do that. What you tend to do is, again, as far as possible, you design the system to do specific tasks, and you try to, once you get a configuration working, as far as possible, you try to keep it that way. Second thing, there's no immediate need for networks because there aren't many computers, and because they're designed as standalone machines to fulfill particular tasks. What do you need a network for, right? You have this computer in one place, it does what it's supposed to do. There's not really any other computer to connect to, and even if there is, what would you do with that? So Pre-1960, there wasn't much need for networks either. And even if you did set that up, it's hard to imagine it would be cost effective, right? If you set up a direct network link to one machine, it's not at all clear that that's better than, say, writing some stuff on paper, dropping it in the mail, and just carrying the documents over to be entered in by hand, depending on what you're doing. So network transfers weren't really practical. Even if you were going to do some sort of like magnetic tape reading machine, which they did have in those days, if you were going to do something like that, then yeah, you could record all the data on tape and carry the spool of tape over and copy that. And that would save you the trouble of designing a whole system to carry that data. All right, so that was the state of things pre-1960. By the way, I'll take a minute. We'll do a little side detour into the internet here. So if you want to see what computers look like in the 60s, right? In the 60s, that's when you see the computers looking like, basically like big refrigerators, right? So you see them in the old-timey movies, and 1964 computer. Let's see how that goes. Ooh, they have the ones that look fairly modern, right? But yeah, a lot of them, the mainframes, right? So 1960s mainframe. Let's see what we got there. There we go. Yeah, some of these are the ones that you see, right? And the old-timey ones, they look like that with the big spools of tape, or like here, they look kind of like washing machines, refrigerators, whatever. But the really old ones, we had that a second ago, they looked more like that, but I'm trying to find a better one. So 1950s computer. They looked like a demented erector set with a whole bunch of switches and things hanging out, right? It looked kind of more like this. Yeah, so first computer from the 1950s. So that's what it looked like. It was not very, I don't know, elegant was maybe the word you would pick. It didn't have all the details covered up inside a housing. So you just flip the switches. Anyway, all right, so that's the way things were back in the day. Okay. Key stuff, capabilities, they were very slow. Computers in the early days were very, very slow. The famous data point that gives you an idea of how slow they were. So you know the moon landing happened about 50 years ago. And when you see those videos of it, right, you see the old movies of NASA, basically have like a giant room full of people, full of computers, and that's all the equipment they used for the moon landing. Well, all of the power of those machines back when put together was approximately the power of one 486 machine, which predated the Pentium 586, which predated all these multi-core machines you have now. A Pentium 486 machine from about 30 years ago, which you could buy for a few $100s. Well, probably more like $1,000, but still. Anyway, so what I'm saying is that's how weak those computers were, right? What used to be a whole, warehouse full of computers within 20, 25 years was the power available on one computer. And the power available on one computer 25 or 30 years ago is just a tiny fraction of what's available now. So the speeds on those would be something like maybe 25 megahertz. Now computers are over 100 times faster, plus they have multi-cores. Hard drives in those days might have been like 20 megs. Now, of course, terabyte hard drives are the standard. So data is actually, more than 1,000 times, right? So several thousand times larger. Anyway, all the computing equipment, vastly, vastly, vastly more powerful. Okay, so cost of it though, hardware was really expensive back then, right? Because part of it was new and it was different, and they didn't have economies of scale for producing it. Okay, and they were still learning how to do it. Yeah, software, such as it was, software was pretty expensive because it was done by hand, but still nowhere near as expensive as hardware. And then operation and modification. Again, because these computers, they were designed to build a special single task, right? Programming it, changing it into some different task was a real headache. So as far as possible, you did not want to have to change those applications. It's not like it is now, where you can just change the code a little bit and it's easy. All right. And certainly they didn't have modular code the way we do now. So these days, right, I'll mention this. We'll go to Paint. Okay. Modular code is one of the great software innovations of all time. Okay, this is a big deal. So back in the day, you had an entire program. Okay. Back in the day, you would write an entire program as one long chain of statements. Okay. And depending on the execution flow, you could bounce around to various parts of the program, okay, which were not modular. That meant if you changed any part of the program, you had to be aware of any possible changes caused for other parts of the program that jumped into that changed point. Okay, so for example, you might have one part of your code, all right, so I'll just write in, so code 1, code 2, code 3, whatever. So code 1 jumps into a specific point of code 2, which jumps into a specific point of code 3. Okay, so if you change code 3, you need to make the changes for code 2, because now it's going to be entering into a different part of code 3. But that means you also need to, or might need to, update code 1 for that change. So the point is, any change you make in these kind of programs is going to tend to necessitate a cascade of other changes throughout your program. It's not quite as bad as rewriting the entire application, but the point is, you make changes in here, it's going to affect how the whole program runs, and you have to account for that so the program doesn't crash. On the other hand, with modular code, you basically build your code in modules. Okay, so you say, here's code 1, here's code 2, and here's code 3. By having this these chunks of code, okay, by having these chunks of code not directly jump into each other, right? Instead they operate by sharing data through standard interfaces. They don't need to be changed when other modules change. Okay, so instead of having code 2's sequence actually just jump into the middle of code 3 at some point, instead, what you could do is say, code 1 is going to exchange some data back and forth with code 2. Code 2 is going to exchange some data back and forth with code 3. And as long as that's kept in a modular way, the big thing with this is I can make any change in code 3 as long as this interface doesn't change. I don't have to worry about these changes. So modular code made it very, very easy to change code. But people only realized this was a big deal when changing the code frequently became possible. Okay? In the early days in the 1950s, where changing a program meant flipping a bunch of switches, you just didn't want to do it, period. But as the interfaces started getting easier, yeah, people started changing code a lot more. But once they started changing code a lot more, then people realized, oh, yeah, we need to do something like this kind of modular code that's going to make it much easier to deal with the consequences of changing the code. Okay. That's a little side thing there, but okay. So then you had the early years, the 30 years or so prior to the internet becoming a big thing. So in those days, the internet population, there were small groups of users who tended to be highly proficient, highly technical. A lot of it was for military or scientific research or for other government groups. A lot of the rest was just for people in universities that, you know, were maybe not actually affiliated with a research group, but they were close enough in that kind of circle, they had access to the internet. Now, in those days, networks were not very big, right? They say limited in scale, but designed to be very efficient for specific purposes. So what you had in those days, the way networks were back when, okay, this was, whoop. Okay, so suppose you have a business, your operation, a large business or research center. Okay, big enough to need multiple computers, which was something of a rarity in those days. So you might have 4 different computers at various locations, but close enough that you wanted to connect them. Okay, which takes a lot of wire in those days. Well, I mean, it still does, but you know, it takes a lot of wire. You don't want to build some kind of cross-country connection. A lot of wire and maintenance, installation and maintenance. So you want to keep these operations pretty compact in, you know, in those days. So you connect them all. This is great. Everything's connected to everybody else. They all have their stand. Actually, what it probably was is more like this. You probably had a big hub in the middle. So we'll just mark that hub. Okay, and you connected everybody to the hub. Okay, now the hub is basically a dumb echo device. Signals come in and are echoed out to all connected machines. Okay, so that's what the hub is. So if I want to communicate this guy to this guy, well, I send it into the hub. The hub echoes it out to everybody. And if you're the intended recipient of the data, then you listen to it, you accept it, you process it. Otherwise, you ignore it. Okay, so each message is designated as, you know, for a particular recipient. Computers not receiving the message will just ignore it. Okay, that's the way it worked. Okay. Now, one of the issues, you have all of these different little networks, and people had to design their own special communication protocols, right? So let's add that. These networks were small and new with no standards, right? With no standard protocols, no standard way of actually doing things. So they might all devise totally unique communication models. Okay, they're all doing it differently. Now, when you blow this up to the level of an entire country, you get something like this. So I'm going to draw a really shitty picture of the United States. So it's going to look something like, I don't know, it points up there, and I don't know, there's Florida and Texas. I don't know, something like that. Okay, that'll do. So you had like pockets here. Twin Cities was actually a significant thing back then as far as computing. Where else? There's New York, DC. I don't know. Let's put one in Chicago for the hell of it. Okay. So what you start seeing, networks arising all around the country. Well, what does that mean? Well, they all with unique or at least different communication models. So how do these guys interact? Well, if this operation owns this set of machines, right? I could say this group has agreed on how to share data, right? They have a model in place. This group also agrees within its own network, but not with any other network. So they need to find some way where these different network models, where they can communicate with each other. Okay, they basically, to communicate, these networks need to agree on a common protocol. Otherwise, can't share data and don't network, right? Unless they can communicate with each other, they don't have a way to do that. So what happened is basically one at a time, different networks would connect and they would say, okay, we'll communicate this way. We'll communicate this way. And they would agree on it, right? So they would come up with something like, damn it, I'm gonna blow that down a bit. Like maybe this network agrees to communicate in green. And this network agrees to communicate in red. And this network agrees to communicate in blue. Okay, I'm gonna actually blew that up. There we go. But what happens when they connect with each other? Well, eventually, right, all of these networks, boom, they're going to have to agree to communicate in the same way. And maybe what happens is this subpopulation gets very large. Bloop, 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 bloop. And because they're so large, they basically say, you know, there's hundreds of us, there's a few of you. If we're going to communicate, we're going to do this, you know, if you want to join with us, you're going to have to communicate our way. Okay, so what happened in practice, without any formal government mandate to communicate in a particular way, these various networks were motivated to develop a common communication model. Mostly driven by early adoption and popularity. But what happened? So if you were the guys who were there first and you had built up this big cluster of networks and you had your communication model there and you were happy with it, and there's a couple other networks on the outside that want to join up with you, you're going to say, well, there's 100 of us or 1,000 of us, there's like 3 of you, we're not going to shift all of our operations to join up with you, right? You can join and use our model that we already have. But if a smaller network had a good idea, that could always be implemented in the next, in the next protocol version. So over time, all of these communication protocols got updated, right? They didn't just wake up one morning and say, here's the standard HTTP that we're going to use. You know, it went through a whole lot of iterations and updates and reversions. So anytime somebody had a better idea about how to do things, yeah, they would eventually get included. For example, right, these red machines, they might be using a different kind of hardware. And for them, this whatever blue is using isn't that great. They could do better. Well, if these blue systems get updated to use the same kind of hardware as red, they're going to say, oh, well, now we see why red's model makes sense. Let's include that in the next version of our communications protocol. Okay, so that's what happened. Over time, everybody was motivated to come up with a common communication framework so they could all communicate. And it was mostly driven by the fact that whoever got there first and established that communication protocol, the other ones joining in would tend to go along with the flow. Okay. So that's what we say. So these networks, they tended to be small. They weren't like the giant intranet of today. They tended to be fairly small groups of machines. And because the hardware was kind of crappy in those days, they tried to squeeze the most usage out of it they could. So they were very clever about devising particular communication models that would work really well on the particular hardware they had. But they weren't necessarily going to work especially well on a different kind of hardware. And that's another one of the problems that you had when you had networks joining with each other. Communication model that's good for one might be terrible for another. So implications of all this. Number one, these early networks were fairly inflexible, right? You would buy machines and expect them to last for a long time. You designed communication protocols for those particular machines and their limited capabilities. You didn't want to swap out the old machines with new ones because that meant maybe you'd need to redesign everything. It was a big hassle, okay? As the need grew for these computer systems to get bigger, right? So by the 80s, a lot of these big organizations, they were having to make pretty frequent changes to their system, just like we saw with modular code. In the early days, when changing code doesn't happen very often, you don't see the need for modularity. This is the same thing with networks. Early on, networks were really inflexible. People didn't see the need to design them in a modular way so they could be changed easily. So by the 90s, though, you had this real need for interoperability, the ability for systems to communicate with each other in a more flexible way because there were a lot of changes. You needed the ability to change the population of machines because if demand for, these networking capabilities is growing, you're going to be fairly constantly adding on new machines, and that's a change to your system. It has to be able to grow easily. Okay. Couple side topics, and then I guess we'll call it a day. So first one, packet switching. Okay, so packet switching. In the early days, you had what was called circuit switching. Okay, circuit switching was favored by the telecom companies. Let's talk about what it is and why they liked it. So, what it meant, each pair of machines in communication used a dedicated line. Okay, and this is basically the long distance model of those days, just like the long distance calling model for telephones. Now, what this meant that calls or other communications were expensive because you were basically renting a long, 100+ miles copper wire for the duration of the call. Okay, and back in the day, circa 1980, a long distance call to we had some relatives that were about an hour's drive away. That was around the order of 50 cents a minute. So it was pretty expensive. It was pretty expensive to rent that copper wire. Okay, so we'll say telecoms loved this. They had no compelling need to offer or develop a cheaper alternative, and thereby cut into their business, right? They already had a good thing going. When people wanted to communicate, they gave them the dedicated line. The quality was pretty good, and they made a lot of money for it. So I should say, in fairness to them, in fairness to the telecoms, this dedicated line model also did give good call quality and, for data, base and isolated data transfers from, whatever, from other users. So it was good, right? It was not all bad, but it was definitely very expensive. Okay, packet switching though, packet switching is a little bit more complicated. Number one, favored by the tech people. And we should add technically superior in providing, adequate service at vastly lower cost. And we'll say universal today. I mean, you can set up a system where you have your own dedicated line, but it is unusual. Okay, what we see now in virtually all systems, we see this kind of packet switching model. What is packet switching? Well, in a dedicated line model, suppose we have three communication pairs, right? We have a red, damn it, come on you. Red, green, and blue. Oh, okay, well, fine. You can be green over here then. Whatever. And they want to communicate with each other. Well, in the circuit switching model, you would need three separate lines for that. Okay, so they're each going to communicate over their own dedicated line, and this green's communicating with that green, but whatever. They're all going to communicate separately over their dedicated lines. However, in the packet switching model, I'm going to finally correct this, they share one line. So let's add this. In the packet switching model, messages broken into packets, right? So small segments, small segments, and the users share the line. And the reason why this works, if you think about it a little bit, is that even during like a phone conversation, users aren't talking the whole time, right? I say something, I pause, I have pauses in between words. There's points where the other person is listening and where the other person is contemplating their response. There's going to be a lot of gaps in the conversation. It's not just an unbroken stream of data. So it would be possible for two users on a phone call to do this kind of packet switching, right? If there's a noise, you take that segment and you capture it and you send it out with an appropriate delay. But if there are others, if it's quiet, then you have no data to send. So same kind of thing, if you have these ongoing intermittent communications between three user pairs, you can send out their data at various times, okay, as needed. And they share the line. Okay, this means number one, you don't need a dedicated line between every pair of users. You make better use of the capacity you do have because all of these gaps in the communication, you're actually filling with something. And it makes it a lot easier to plan around capacity issues, right? So it's not that if you have more users, you need a lot more lines. And so the variation in how far off you are in the number of users is going to determine how far off you are in terms of capacity. With packet switching, you can add on more lines, But if you're wrong a little bit, what happens is you can just try to cram messages in a little tighter, for example. You can sacrifice a little bit of the message quality, because there's a lot of communications that don't need to be perfect, right? I mean, if you're talking about transaction processing, those kind of data transfers, sure, those need to be adequate. But if you're talking about video stream, for example, you can video stream in high or low quality. If you're sending audio, you can stream that in high or low quality. So it becomes much easier to manage quality of service as well. Okay, so advantages. Cheaper, easier to manage quality of service, and plan for capacity upgrades. Okay, so packet switching, very nice thing. It's what's widely used today. And again, as opposed to circuit switching. All right, other thing I want to talk about briefly, Ethernet. Now, we know Ethernet, right? In fact, I just briefly contemplated using an Ethernet cable a few days ago. We just installed an Orbi system for a mesh network for our Wi-Fi in our house. And we were having some troubles around that at first. And I thought, you know what, I could just plug an Ethernet cable straight into our router. But then this was for my son and his connection with his school stuff. But they gave him a cheap Chromebook that doesn't even have an Ethernet port. So that idea went out the window. Anyway, so Ethernet, right? It's these cables, Ethernet cable. These, and you've all seen them, right? Typically yellow or blue, but you know, other colors are available. What happened with that? How did Ethernet become the big thing? Well, I'll briefly talk about this. So Ethernet, widely used standard for wired communication, right? As opposed to Wi-Fi or 4 or 5G, okay? So those are types of wireless ones. So Ethernet, if you actually hook up computers with a cable, chances are you're doing it with Ethernet. Well, back in the day, there were other competitors to Ethernet, notably token ring bus. Okay, so the idea with if you have a group of computers all networked together, you need to find some way to regulate who can transmit. Because if they all try to transmit at the same time, it'll be like a crowded room with everyone talking, and no one will be able to understand what's being said. Okay, so that's what we want to do. If we have a bunch of network computers, just like we saw with our hub in the middle, the hub is an echo device, but if I have a bunch of computers all talking at the same time, what's going to come out the other end is going to be a bunch of garbled gibberish. So this is a problem. Now, without getting deep into the technology, again, token ring was one. Token ring worked really well, but the equipment was expensive. Ethernet worked well enough, and the equipment was much cheaper. Okay, this was going in. Over time, because the best solution, right, the technically best solution is not always the practically best option, right? So think cost effective. Not everybody, you know, everybody might need a car, but not everybody needs to have a super expensive car. Just like all these businesses needed networks, but they didn't all need to have top grade networks. So because the technically best solution was not always the one the businesses were going to pick, Ethernet became more popular, which gave economies of scale to its production, which kept pushing the prices down. Okay, which swung the balance even further toward it. Okay, and eventually token ring just kind of went away. I mean, you could still get the stuff if you really wanted it, but it's expensive, and Ethernet is good enough these days. Okay, certainly, you know, it's the same model. It's all higher capacity, so you can get Ethernet cables that do, you know, that have many gigabits per second capacity. You could develop a similar model with token ring, but Ethernet works well enough, and it's very cheap, so that's what people go with. Okay, and that's why we have Ethernet instead of one of these other models. Okay, so I feel like this is a good break point. So I am going to stop the sharing now. And likewise, I will stop the recording. But if people have questions, if people want to talk about